Hey guys, so today I want to tell you about our mini project, Bloomberg, plant care automation. Now, before we get started, dive right into what's the project about, I want to start with a backstory. So in Sem 5, we had decided to make a facial recognition attendance system in Python using Flask. And the project overall was good, technically good. Requirement-wise, we didn't quite reach there. So like during the final external review, what the external said to us was that the project was half-baked. What we had basically implemented was you could like show the camera to your entire class, like move your phone to the entire class, and it will scan all those faces and mark their attendance, put it in an Excel sheet for the teachers, combine those Excel sheets and stuff. It was very good technically, as I said, but it didn't quite reach there. The sir was like, so you expect me to move my phone to the entire class before every lecture, is what he said. And it made sense. The technology is, if we are introducing some new things, it should be frictionless, right? So that's when we thought that, yeah, this project was good overall, but we need to do better from the next sem onwards. And that's where the next part comes in, the learning. So the learnings that we got from our facial recognition attendance system was, the very first learning was compatibility issues across multiple devices. So one of our team members was working on macOS, and me and my other third team member was working on Windows. And it just happened so that the library that we were using related to facial recognition was like, if it's working on my laptop, it was giving issue on my friend macOS laptop, and not laptop, whatever it is, and basically vice versa. So that was one of the compatibility issues we faced. Like we tried to solve it, but later on we just split the work in half. Then I was working on the other requirements, the other features, rest of the features. He was working purely on those facial recognition features. But yeah, that was one of the learnings that we need to make our software is that it should work across all the platforms. And we researched about it, how to make it possible. And that's when we came across Docker. So we thought, yeah, from next on sem onwards, we are going to be using Docker. Now, the other learning that we came across was our solutions should have real-world actual actuators. I know, it sounds weird. Actually, the precise term would be the real-world automated actuators. Like in a facial recognition attendance system example, we should have implemented some degree of IoT, I guess, so that the camera should move automatically across the class or something like that, so that the teacher doesn't have to do the work. The aim was to reduce their work, right? Let it be teacher or in office itself. Still, there should be automation in such stuff, actuators. So yeah, those were the two major learnings in our project. Rest, we were able to work as a team. We knew how to use GitHub. The project was entirely done on GitHub itself. And like, I would say 75% of our peers don't even know what GitHub is. And I would say out of remaining 25%, only 5 or 10% of them actually used GitHub for their project. Because what was happening across different groups was only one member was working. So there was no particular need for GitHub. But yeah, those were the learnings. Now let's move on to the next chapter, the lazy. Alright, what I mean by the lazy is that we engineers are lazy. We are lazy people, alright? We would rather spend enormous amount of time and efforts on automating something rather than doing that task repetitively. So one of these examples in my own house was watering plants. I have a lot of plants, and I find it boring, like repeating the same thing again and again every day. And I thought to myself, this should be able to like easily be automated, right? At cheap cost. So yeah, that's where the real project inspiration begins from. And yeah, that was the lazy part. Let's move on to the next chapter, the ambition, reality, and in between. So as our generation knows, there's climate change, water scarcity, overpopulation, you name it, we have those issues. And one of the sectors that needs major focus on is the agriculture sector. It needs the technology to be infused in it. We need to automate production of food so that like we can support this ever-growing massive population growth. And yeah, that's what the aim was. Like that's what I started to think when I wanted to do this plant care automation. Originally, we had fixed upon agriculture care, right? Not just plant care. And that was the ambition. Then the reality hit us, and the reality was that we had zero domain knowledge, and yeah, we didn't have no knowledge whatsoever, but we wanted to start in it. Now, like, we have always seen such codes that don't set a far off unknown goals, rather set small goals to which you can make your path. So that's when we thought, okay, let's scale down our expectations from agriculture to small scale plants in my balcony itself, the original issue, the problem statement. So yeah, we scaled our expectations, and that brings us to the next chapter, the implementation. Perfect. All right, so the implementation chapter. This one is the interesting one, the one you would be main concerned about. So before this project started, me and the same mini project group, we had participated in ONDC Build for Bharat Hackathon. And in that, we had used MERN stack to solve those problem statements given to us. So we had some basic idea, not complete, but a basic idea of what MERN stack was and how to make stuff with it. So the college had given us a bunch of frameworks to choose from: MERN, MEBN, Flask, Unity, etc., etc. But we thought, yeah, since we have already done a bit of research in MERN stack, why not just continue it in it and grow our knowledge more? So we continued with MERN stack, and that's how the application, the user end of this project comes about. We have MERN, that is MongoDB, Express, React, and all of this stuff, React and Express on Node.js. So that's the front end part of our project thought about, right? Like the user part. The back end part was still a bit of confused. How do you actually automate plant care? We did a bit of research, we studied a few papers, reviewed a few projects, and we noticed that a lot of people were using Blink app paired with Arduino, or its cheaper but powerful Chinese counter opponent, rival, NodeMCU. So yeah, so one of the things about IIT project is that it needs to be cheap, right? And Arduino, we just didn't feel like Arduino was necessary for this project, so we went with NodeMCU and soil moisture sensors, pump, sensors, actuators and stuff, everything. And learning those things were massive growth to be honest. But we faced a lot of issues with NodeMCU. As I said, it was the first time experience for us, but we didn't give up. 6 months of hard work, and we were able to implement a good multi-platform dynamic application, and a fast one, to be honest. And yeah, our goal was to make it user-centric. We achieved that goal. Our goal was to make it transparent to users, show them as much insight as possible. We achieved that as well. And at the same time, we kept the application as simple as possible, because it should be able to use by anyone. Thing about Blink was you have to set it up yourself. And Blink, I wouldn't say there isn't proper learning when you use Blink. Blink is Blink is a good application, I would say, but it's for when you want to automate for yourself. And we wanted to make this project such that you can order it from our website, and all these things, all those details of those devices will be visible in your dashboard. And we were able to obtain it. We were able to achieve it as well. Which brings us to the next part, the takeaway. Alright, so what were the takeaways? While making this project, we tried to make our website as realistic as possible, what you will have in a real world, not just made a project that will sit and rust away in your project's portfolio. So yeah, while doing so, we learned a lot of things, I would say. And it was more of, we learned less with the easy part and more with the errors. Because when you face errors, right, that's when you actually start to understand what's happening here, what's happening there. And yeah, even though errors were annoying, but those were the real things that made us learn about the MERN stack, the Arduino IDE, sketches for the NodeMCU. And yeah, I'm really happy with what we have made. And if any of you are actually interested in trying this device, well, we haven't actually made the payment portal on our website, because that brings legality and stuff in it. We don't want to go into that right now. But if any of you want to actually try out this project, we would consider giving you the device itself on cost to what it costs us to make. And you can try it out for 1 month, 3 months. If you like it, if you don't like it, you can just return it to us. We'll refund you your money and stuff. But yeah, what are the those are the takeaways. Now comes the future scope. So as I said before, that we had scaled down our expectations. So this original problem statement of this project itself was taking care of one plant. But that's not realistic, right? You can't have one device which costs around 650 for a single plant. So we started our work on multiplexing this device, and we were able to achieve a certain degree of multiplexing, after which we realized that we need to optimize our code. And yeah, that's the future scope of our project. We actually need to optimize our code so that it can handle up to 8 devices at the same time. We also thing is, we are collecting data, right? Plant data. And user can put in description what type of plant is the sensor for. So over the project, we learned a lot about plants as well. How when you water them initially, the water flows down into the tray and then it gets absorbed back again by the pot. When did we first learn about this? Was when we made a very initial first run. Okay, the water pump turned on, it watered the plant, the water flowed down, the soil moisture took readings again, and now even though there was enough water for the plant, the soil moisture was on top of the soil. Water was over here. So it became dry over here again. It watered the plant again, the pump, and now we had excess water, which wasn't necessary. So we introduced cool down to it. When one pump is turned on, it has a 6-hour, 12-hour cool down before it can be turned on again. The reason we introduced this was this only, the water is collected in the tray and it gets slowly absorbed in your plant. So the moisture graph goes like this. It peaks and it drops instantly again after the water pump, but it slowly increases again. All right. Next, I would say the future scope is, since we are collecting data on these different plants, the soil moisture levels, the watering, the amount of water supplied to them and stuff, I feel like that's a good, I wouldn't, right, as of right now, I don't know what's the good use of those data, but we have thought about implementing a model which would predict after how much time has elapsed that the water pump will be turned on for your current criteria. So the user can set how much threshold they want, 75%, 60%, and all in all. So yeah, those were the future scope. And overall, I'm very grateful to my team members, to our guide as well, for helping us make this project possible, come into actuality. And yeah, I hope you make such projects as well, which can actually impact real world problems instead of simply just going through the tutorial help, making clones and stuff, which helps you gain knowledge of how the software works, but somewhere along the line you get detached from reality, which isn't really good, right? So yeah, thanks for watching this video. And yeah, if you want a product demo, you can go into the link below in the description, where we have put the website link. And the thing about our website is it is deployed, but it's in the free tier of render. So it sometimes might not be, the website will load, but our backend is free again, and it spins down after a bit of inactivity. So if it's loading, I know loading is annoying, but give it a 1 minute. After 1 minute, it loads the entire page, and then you can browse freely. Anyways, thanks for watching. If you like this video, make sure to hit that like button, subscribe to my channel, press the bell icon for any latest videos, updates. And yeah, once again, thanks for watching. These are some videos from my channel if you wanna take a look at them. Bye.